This is the video for Bridges section 8.3, the quadratic formula. Now previously we talked about solving quadratic equations, we talked about factoring. But you and I both know that not everything is factorable. Well, the quadratic formula is another way you can solve quadratic equations, and this is a way that will always work whether the particular quadratic is factorable or not. And so, the quadratic formula itself is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's, of course, if you're solving something that looks like ax squared plus bx plus c equals 0. So this right here is the formula. If you ever need to remember it, there's a nice little song to the tune of Pop Goes the Weasel. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. I'm not doing that again. Now, one thing that you can glean from this information is what's called the discriminant. The discriminant is b squared minus 4ac. So if you notice, that's the piece of this formula that's underneath the radical. And so, there are three cases. If b squared minus 4ac is positive, then you get two real solutions to your quadratic equation. If b squared minus 4ac is 0, you get one real repeated solution. And if b squared minus 4ac is negative, you get two imaginary solutions. So that's what you can use to tell what you're dealing with ahead of time. So let's do some examples. Negative x squared minus 4x plus 8 equals 0. Now, if you notice here, what we can do to make this a little easier on ourselves is we could just multiply both sides by -1. That way I can create more positive numbers. So if I multiply both sides by -1, that'd be the same thing as x squared plus 4x minus 8 equals 0. Okay, so at this point, we can write out our formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You should always write out the formula every time you want to use it. So, if you notice here, a is 1, b is 4, and c is negative 8. So what we can do is we can fill this in. So x equals negative b would be negative 4, plus or minus the square root of b squared, 4 squared is 16, minus 4 times 1 times negative 8, all divided by 2 times 1. So, if we start simplifying this, this is negative 4 plus or minus the square root. Now observe that this minus sign here and this minus sign here are going to change that into a plus. And 4 times 8 is 32. 16 plus 32 is 48. 48. All divided by 2. And we have to simplify the square root of 48. Remember, this acts like a single 2. This acts like a single 2. 2 times 2 is 4, and there's a 3 left over. So this is negative 4 plus or minus 4 square roots of 3 over 2. And notice that both of the 4's are divisible by 2, and you end up with negative 2 plus or minus 2 square roots of 3. All right. 18x squared minus 24x plus 8 equals 0. Now notice here there's a common factor of 2, so what I can do is I can just divide everything by 2, and that'll make the quadratic formula easier to do. It'll make the numbers smaller. So if I divide everything by 2, I get 9x squared minus 12x plus 4 equals 0. Observe this time that a is 9, b is negative 12, and c is 4. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so if b is negative 12, then negative b is positive 12. Because that negative just basically means change the sign. Plus or minus the square root. Now, technically speaking, here you would be squaring negative 12, but I never write that there, and here's why. Whether that number b is positive or negative, when you square it, you're going to get a positive value. So you can just treat it as a positive 12. 12 squared is 144. Because if you're not careful, when you type that into a calculator, you'll get negative 144 if you don't type it in right, and then that throws everything else off. So 144 minus 4 times 9 times 4. 4 times 9 is 36, times 4 is 144, which is kind of cool. And this is 2 times 9. So notice that this over here becomes 144 minus 144, which is 0. And the square root of 0 is 0. And 12 plus or minus 0 would be 12. So this comes out to be 12 over 18, which is 2/3. One thing that you can tell if you're doing the quadratic formula, if your square root simplifies all the way, that means that your original equation was factorable. So this one was that we started out with was factorable, but you can still use the quadratic formula to solve it. (2x squared minus 4x plus 5 equals 0. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Notice here that a is 2, b is negative 4, c is 5. So x equals 4 plus or minus the square root. B squared would be 4 squared, which is 16, minus 4 times 2 times 5 all over 2 times 2. Okay, so 16, 4 times 2 times 5 is 40. 16 minus 40 is negative 24. So this is x equals 4 plus or minus the square root of negative 24 over 4. So we got 24, 2 and 12, 2 and 6, 2 and 3, pair of 2's, 2 times 3 is 6, so that would be 2 square roots of 6, but because that's negative, it'll come out imaginary, so that would be 2i square roots of 6. X equals 4 plus or minus 2i square roots of 6 over 4. Notice that the 4, the 2, and the 4 are all divisible by 2, so this would be 2 plus or minus I square roots of 6 over 2. And that's really all there is to the quadratic formula. Basically, the hardest part of using the quadratic formula is being able to simplify it. That's what a lot of kids tend to struggle with. The assignment for this section is on page 530, 17 through 26.